Now let us study algebra of events, that is different operations that we perform on events. This also has a direct analogy with the set theory. First, we have the complement of an event E, which is denoted by E dash or E complement. Now that is nothing but the set of all outcomes which are not in event E but which are within the sample space. So here you see the green shaded portion which is outside the event E but inside the sample space, that represents the complement of event E. Second is what is called as the union of events A and B, and that is denoted by A union symbol B. Now here it is nothing but the region covering A and B together. Alright, so that includes the part which is purely in A, the part which is purely in B, as well as the part which is in A and B both. So here we see the union region also shaded on the right hand side diagram. Third one, we have the intersection of A and B. It is denoted by A intersection symbol B. You see the symbol of intersection is just the inverted symbol of the union. And by intersection we mean it's the region which is common to both of A and B simultaneously. So that is what is the common region between A and B shown on right. And lastly, we have an event of the type it is A but not B. Alright, so it means that it's the region which belongs to A but not to B. So in other words, it is nothing but the intersection of A and B complement, that is A intersection B dash. So on the right hand side you will see that it's the region which is within the boundary of A but it is not in B. So it's that portion of A which is not in B. So similarly we can derive many such different regions based on the various conditions, but these are the four main operations that we do most frequently on the events. Now let us move ahead and see some of the standard results related with these operations. Alright, the first one is P of E plus P of E dash is equal to 1. Now this is evident because the region indicating the event E and the region indicating E complement together will definitely make up the sample space, and there is nothing common between these two, so therefore their probabilities will add up to 1. Now the second result is what is called as the addition theorem for probability. It says P of A union B is equal to P of A plus P of B minus P of A intersection B. Now this also directly follows from the corresponding result from set theory, where instead of P we have all number of elements in those respective sets, and when we divide that result by n of s, which is the number of elements in sample space, we get this particular result number 2. Now this result can be extended to any number of events. So third one is just further generalization of that result, that is instead of 2, if we have 3 events A, B and C, then probability of union of all of those together is given by probability of A plus probability of B plus probability of C. So that means first we add the probabilities of events taken one at a time. Now from that we subtract the probabilities of intersections of 2 events taken at a time, and lastly we add probability of intersection of all the events taken at a time. So it is alternate plus and minus that we have to do with these different sets of events. Now this is also called as the principle of inclusion exclusion, because we are alternately including and excluding the different regions as indicated here. Fourth one is probability of A intersection B dash is equal to probability of A minus probability of A intersection B. Now this is also evident from the figure that we have seen on the previous slide, that is the event A intersection B dash on left hand side indicates nothing but it's the portion which is inside A but outside B. So therefore from the region of A, we have to remove the region which is common to A and B. So therefore we have to subtract P of A intersection B from P of A, which is the right hand side. And lastly we have another very important set of rules called as De Morgan's laws, which are nothing but probability of A union B whole complement is equal to probability of A complement intersection B complement, and its counterpart is probability of A intersection B the whole complement is equal to probability of A complement union B complement. So we use these rules to solve basic examples on the algebra of events. Now let's see one more terminology related with the probabilities of an event and its complement. First one is what is called as odds in favor of event E. Now this is given by probability of event E divided by probability of complement of event E. So that is P of E upon P of E dash. So it's nothing but the ratio of probabilities of occurrence of event E and non-occurrence of event E. That is called as odds in favor of event E. Now if it is opposite, that is odds against event E, that is nothing but the reciprocal of the previous ratio. That is, here odds against E are given by P of E dash upon P of E. Alright, so these are only two specific wordings or phrases in English which we have to remember as these formulae.